If you've ever felt the sheer frustration of copy-pasting boilerplate pipeline code across multiple environments only to spend 2 grueling hours debugging why your test deployment accidentally hit production, then this video is your blueprint for escaping that manual, costly error cycle. I'm Maxim, a software development consultant. Here on my channel, we dive into real-world development cases, showing you how software solutions are built and deployed in practice. Subscribe to my channel if you want to see more videos like this. Today we are tackling something that every Azure integration developer eventually faces: deployment to multiple environments without losing your sanity. We are building a single, reusable Azure DevOps pipeline that deploys to dev, test, and production environments without changing a single line of code between deployments. Sounds too good to be true? Grab your coffee and stick around. Let's dive in. Picture this. You've got an Azure DevOps pipeline that deploys your integration solution to a dev environment. In our case, we're not just deploying to one resource group. We are deploying to multiple resource groups that together make our complete integration environment. Maybe you've got one for logic apps, another for API management, one for storage accounts, and so on. They all live happily together in the same Azure subscription. This is our starting point. One pipeline, multiple resource groups, one subscription, life is good. But here's where it gets interesting. Now we need a test environment, and because we are responsible developers who care about separation of concerns, and also because our security team will have our heads if we don't, this test environment lives in a completely separate subscription, right? Same resource groups, same structure, different subscriptions. It's like having an identical twin but in a different dimension. And of course we need production environment. Another subscription, another complete copy of our resource group structure. Now we are managing 3 identical environments across 3 subscriptions. The naive approach, copy the pipeline 3 times. The smart approach is what we are building today. So here's the elegant solution to keep our pipeline code identical across 3 environments: Azure DevOps Variable Groups. Think of variable groups as environment-specific configuration containers. Each environment has its own dedicated variable group containing everything unique to that environment, while the pipeline code itself remains beautifully unchanged. Let me give you a concrete example. Imagine you have a logic app workflow that's triggered by an HTTP call, processes some data, and sends the results to an external system. Each environment, dev, test, and production, has its own instance of that external system. This is where variable groups shine. We create 3 variable groups, each containing a variable called, let's say, destination endpoint. Notice the pattern? Same variable name, different values. The pipeline doesn't care which environment it's deploying to. It simply reads from the appropriate variable group that's been loaded for that stage. So what else belongs in these variable groups? Essentially anything that varies between environments. Connection strings for databases and storage accounts, service bus namespace URLs, API keys, and access tokens. Though for sensitive values, you should really be referencing Azure Key Vault. Resource naming conventions, prefixes or suffixes like dev, test, production, prod. Subscription identifiers and resource group names. Regional settings if you're deploying across different Azure regions. Feature flags for environment-specific functionality, for example, API management service price tier. You can use developer in the dev environment, basic in test, and premium in production. The elegance of this approach is in its simplicity. Your pipeline logic becomes completely environment agnostic. The exact same code deploys everywhere, only the configuration adapts to each environment. Pro tip: consistency is everything. If your dev variable group uses destination endpoint variable, then test and production must use destination endpoint too. Not API endpoint, not API underscore endpoint, not API dash endpoint. Standardize your naming convention across all variable groups from day one. Trust me, in future you will be incredibly grateful. Now let's talk about the pipeline structure itself. We are going to organize this into 3 YAML files. Why 3? Because separation of concerns isn't just for code, it's for pipelines too. File 1. The orchestrator. This is your pipeline's entry point, the file you point Azure DevOps to when creating the pipeline. Think of it as the orchestrator. Its responsibilities: define trigger conditions. When should this pipeline run? Declare all the variables that are common across environments. Define the environment stages, dev, test, prod, as objects with necessary environment properties. Control the flow. Should test wait for dev? Should prod require manual approval? This file is all about the what and when, not the how. File 2. The iterator. This is your middle layer, the bridge between orchestration and execution. Its job is to take an environment as a parameter, load the correct variable group for that environment, loop through each resource group that needs deployment, call the actual deployment logic. Think of it as a smart for each loop that knows which environment it's working with. File 3, the worker. This is where the rubber meets the road. This file contains your actual deployment logic, running bicep templates for deploying Azure resources, configuring connections, running validation steps, any post-deployment scripts. It doesn't care which environment it's deploying to. It just takes parameters and deploys resources to the predefined destination. This three-tier structure might seem like overkill for a simple deployment, but trust me, when you need to add a fourth environment, or change deployment logic, or add pre-deployment validation, you'll be glad you organized things this way. Plus, it makes testing and troubleshooting way easier. If deployment to test fails, you can quickly isolate whether it's an orchestration issue, an iteration issue, or a resource-specific problem. And now let's have a look at how the variable groups are organized in the DevOps. Let's go to Pipelines, Library, and here you see the list of the variable groups that I have created per environment. Let's have a look at the development environment variable groups. You see the 3 variables defined here. These variables are used by the solution: destination endpoint, service connection name, and subscription ID. If we go back, and let's see the variable group for test environment, the same variables. You can link your variable group within Azure Key Vault, and this gives you the possibility to use Azure Key Vault secrets as variables in your variable group. This gives you the possibility of extremely secure way of using sensitive data as variables in your variable group, and these values will be automatically fetched from the Azure Key Vault and used in your pipeline as variables. And if you go to the variable group for the production environment, you'll see exactly the same variables. So my variable groups are equal in terms of set of variables. They will have different values. In reality, in my test, I use the same values, but in real solution, of course, you will use different values per environment. And now let's see at how the YAML files of my pipeline look like. So we should go to the code repository. In the infrastructure folder, I have the main pipeline YAML file. So here you can see the variables defined on the root level of my pipeline. Variable group name. This contains only the base name without environment extension. Resource group, where the solution will be deployed to, again, without the indication of the environment. Logic app template path, the path to the bicep file which will be executed. And next in the stages, the template is defined. The template is a template all environment YAML file. And down you see the parameters. The variable group name, resource group name, logic app template path, those which are defined on top as variables. And then you see the list of environments. Environments are defined as objects. And you see here that I have definition of 3 environments. I give a name which will be assigned to the stage, because the whole process of deployment is split to stages. So the stage of deployment to dev will be named deployment dev, stage of deployment to test, deployment test accordingly, and then deployment to prod for deployment to production environment. Each object in the variable in the environments list has a name: dev, test, prod, and this name will be used as the environment identifier. So for instance, variable group name, the variable defined above, will get this environment name in the end, so that the whole name will be abc-integration-dev if we deploy to the development environment, and test and prod accordingly when we deploy to other environments as well. Now let's go and see the template all environments YAML file. It resides in the templates folder. So here you see, first of all, a list of parameters which accepts this YAML file. It accepts the environments, variable group name, resource group name, location, the bicep file path, and here you see that the cycle environment iteration is organized. So the list of environments is iterated, and the environment variable in each iteration is used to specify which environment the deployment will be done to. So we see the definition of dependency depends on, and the dependency is defined per environment in the previous YAML file. And the group, variables group here, should be specified the variable group name, which will be used to provide variables to the pipeline run, to this stage. Then jobs follow, and here for the job I use next YAML file, template for the environment. It will get its own parameters, the environment, literally environment name, dev-test.prod, resource group name, the name of the Azure resource group, which will be used to create the Azure resources in. Here is the parameter logic app template path, the one which came from the main pipeline, where it's defined as the pipeline variable, namely the path to the bicep file, which will deploy my logic app. And the geographical location. This will be used for the logic app and for the resource group if it doesn't exist at the moment of running this pipeline. The resource group will be created in this geographical location. So next is template YAML file, which defines deployment within a single environment. Again, list of parameters, environment name, the bicep file path, resource group name, and geographical location. And here only jobs are defined. It's the deployment job, which defines what will be deployed, defines the environment. This environment will be created in the DevOps. And then the next step is checkout self, meaning that the source code from the DevOps will be checked out. And then the Azure deployment task is used. The task is named Azure Resource Manager Template Deployment. Version 3. It has a list of standard parameters. All they are described in the Microsoft documentation. Deployment name is not so important. It can be whatever you wish. Just give a text which will allow you to identify what was deployed in the list of deployments in DevOps. And the deployment scope is resource group, Azure Resource Manager connection. This value comes from the variable group. So service connection name is defined as a variable in the variable group in DevOps, and it will be taken from the variable group which is specified for this stage in the previous YAML file. This resource group name, again, it's a full name with the environment identifier in the end as a suffix, and it will be used for Azure resources created by your pipeline. Location is, as I said, a geographical location. And the next parameter is CSM file. And here you can see that this is the path to the file. And the path is actual for files fetched from the code repository. Next parameter, override parameters. It's a list of parameters defined by your bicep file. So it's completely specific for how you define your variables, your parameters in your bicep file. In my bicep file, I defined only logic app name and the backend URL. The destination endpoint, if you remember, is a variable in a variables group, and it's fetched from the corresponding variable group for this particular environment in a specific iteration. Action is create or update resource group, which means that your resource group may not exist at the time of running this pipeline. Then the resource group will be created automatically. If it exists, then nothing will be done. So it will be just used for creation of your resources. The logic app name is combined of the fixed part logic-demo- and then the environment parameter, where the value obviously will be dev test or prod. And the last thing is the bicep file itself. So here in top of the file we see the parameters. The same parameters are used in the YAML file. So yeah, the resource is the definition of the logic app, consumption logic app. Now let's get to the action. I will start with creation of a new pipeline. Click the Create Pipeline button. Then Let's select the Git repository. I have an existing pipeline YAML file, so this will be displayed in the path drop-down box. Select it. Then when I click on continue, the YAML file, the selected YAML file will be displayed for the pipeline. I can run the pipeline right now, but instead of running, I will save it first. So it's created with a default name deployment demo and the name of the code repository. So I will find this new pipeline in the list of pipelines, and then I can run it right from here in stages, clicking on the stages to run, and you most probably will get this type of error displayed. If you see what the error is about, it says that the pipeline doesn't see the variable which is used from the variable group. The name of the variable service connection name. The reason is that I've created a pipeline, I use this variable in my pipeline, but it doesn't know where this variable is located, in which variable group. So the next step is to go to editing mode for the pipeline again. And here let's go to triggers. Switch to variables, and then you see the variables group. Here you should link your variables groups to your pipeline. With this, the pipeline will know which variables groups are used and where to look for the variables. Next, run the pipeline again. This time it will run. It shows us which stages exist in a pipeline, and I use the deployment to a particular environment as a stage. So you sort dev, test, and production. It starts running the deployment process. So it fetches the source code from the code repository first. Then it executes the bicep file. And my bicep file creates a logic app. So it's a bit time-consuming process. And depending on the complexity of your pipeline files, it may take up to dozens of minutes. Here you see that the execution of deployment to the dev environment is finished. Then the pipeline runs further. Just the same deployment as was done for the dev environment. No difference, except that the suffix test is used for the resources created. Here you see the DevOps environments. And the DevOps environment allows you for definition of rules, constraints, approvals. For instance, you can define that particular people must give approval to deploy into a particular environment. Or specified code branches are allowed for deployment of resources to a particular environment. Like, it's most probably that you will protect the production environment with deployment only from the main branch, so that you would never be able to run the pipeline which uses the feature branch. But let's go further. The deployment of the logic app is complete for the test, and the same will happen for the production. As you see, the deployment process is completely equal for each environment. Now we can check that the Azure resources have been created by the pipeline. So first of all, you see that 3 resource groups have been created per environment with the suffixes dev, test, and prod, and the logic app has been created inside these resource groups, again with suffix indicating the environment. And the most beautiful part of it is that the deployment to the environment is only specified by environments parameter, which contains the list of environments which we are going to deploy to. So this definition of the environments as the elements of the environments parameter of the template makes it simple to deploy to the additional environment. So the only thing you will have to do to create the staging environment, for instance, you will have to just add a new element to the list, which will be named deployment stage. We will define the dependency. This one may be dependent on the test, and the production becomes dependent on the stage. And that's it. You will get your solution deployed to the additional environment by just extending the list of environments in the parameters of your YAML file. Wait a second, not actually just this thing, but you will have to create the a variable group. And this one can be done very easily by cloning stage. You will set the new values for your variables. That's it. And this suffix stage will be used to find the variable group, because my environment specified as a parameter has the name stage. Before we wrap up, let me share some lessons learned from running pipelines like this in production. Tip 1. Using naming conventions. Postfix your resource groups and resources with the environment name. Instead of rglogicapps, use rglogicapps-dev. This makes it crystal clear which environment you are looking at in the Azure portal, and it prevents accidental cross-environment operations. Tip 2. Leverage Azure DevOps environments. Azure DevOps has a feature called environments. That's perfect for this. You can define approval gates, deployment history, and even environment-specific permissions. Highly recommended setting this up for test and especially prod. Tip 3. Store secrets in Key Vault. I mentioned this briefly, but it's worth repeating. Don't put sensitive values directly in variable groups. Reference Azure Key Vault instead. Azure DevOps has a special feature, Key Vault linked variable groups, so for all parameters, all values which are of any secret, use the resource group linked to a Key Vault so that the values will be fetched from that linked Key Vault. Tip 4. Version your infrastructure. Treat your YAML files and bicep templates like application code. Use branching strategies, require pull request reviews, and maintain a changelog. And that's it. You now have a production-ready multi-environment Azure DevOps pipeline that scales beautifully and keeps your code dry. Dry stands for don't repeat yourself. To recap, we use separate Azure subscriptions for environment isolation. Variable groups provide environment-specific configuration. A 3-file YAML structure keeps everything organized and reusable. The same deployment code runs in every environment. This pattern works whether you are deploying logic apps, function apps, API management, or a complex mix of Azure resources. I've used variations of this for many different integration solutions. If you found this helpful, give a thumb up and subscribe for more Azure integration content. Drop a comment down below if you have a question or want me to dive deeper into any specific part like bicep templates, approval gates, or troubleshooting pipeline failures. The complete code for this pipeline is available in the description below. Until next time, happy deploying, and may your pipelines always be green. Thank you, see you soon.